Welcome, everyone, and thank you for joining us. I'm Brenda Dettinger from BioPack, and I'll be your moderator on today's webinar, Enhancing Psychophysiological Research, Integrating Multimodal Data Acquisition. This webinar is being recorded. We'll send each of you a link once the recording is processed. During the webinar, if you have questions, please submit them through the GoToWebinar control panel. That's how you communicate with me, your moderator. I'll pass on as many questions as I can to our presenters. Before we get started, I have an announcement. We host a biennial human physiology training event, and registration's now open. We'll be hosting this event again in July of 2025. It's going to be here in town at UC Santa Barbara in California. That's down the street from our corporate headquarters. We'd love to have you join us. It's a great opportunity to get hands-on experience with all the BioPack devices, including the ones on today's webinar. Here are just a few of my favorite photos from the 2023 event, so save the date, July 14th, and meet us in California. Now, on to our presenters. I have two fabulous experts today. Tim Cook is a product expert and domestic sales manager at BioPack. He has his MS in health and human development and has over 18 years of experience in the life sciences and physiology monitoring industry. He's very well versed in setting up and running a student lab, running student lab learning systems, and always has a ton of great information to share. Welcome, Tim.
Thanks, Brenda.
We also have Fraser Finlay. He's the CEO of BioPack, and he has over 25 years of experience in the life sciences and physiology monitoring industry. He's a well-regarded expert who presents at workshops all over the world. Welcome, Fraser.
Thanks, Brenda. Welcome, everyone.
All right, Fraser, let's start with you. I'm making you presenter.
Great. Thanks, Brenda. Organized here a little bit. Okay, perfect. Well, welcome everyone to our webinar on multimodal data acquisition. Brenda, thanks for the introduction, and again, welcome everyone. So before we start, I have a little background information about BioPack. BioPack develops high-quality scientific tools that allow you to measure physiology anytime, anywhere, with any subject. We've been in business for over 30 years, and 99 of the top 100 universities use BioPack products. And many of the largest technology, consumer products, and pharmaceutical companies use our products for development and validation. All those customers have helped to generate approximately 54,000 citations that mention BioPack. So today we'll look at the multitude of devices that can connect to AcqKnowledge. AcqKnowledge communicates with all these devices to provide a wide range of options for most lab and remote use cases. AcqKnowledge is the center of everything we'll be demonstrating today. So BioPack's complete line of data acquisition platforms all come with AcqKnowledge, whether that be an MP200, MP36, Smart Center, etc. To the previous generations, such as the MP160 and the MP150. So pretty much if you're using one of our systems, you should have AcqKnowledge or a license to AcqKnowledge. The software seamlessly integrates with webcams to combine behavioral data with physiological data. This is the best way to help identify artifacts and understand your data. The video is synchronized to the physiological data for playback. AcqKnowledge also integrates with a range of eye trackers from iTech, iLogic, and Tobii. The eye trackers integrate with AcqKnowledge via the stimulus presentation system that allows you to create areas of interest and easily combine eye tracking with physiological data collection. Excuse me. No electrodes required, just a well-positioned webcam and good lighting. The face reader software provides real-time feedback regarding the participants' facial expressions and combines with our remote eye tracking software. For those of you that have mobile participants, AcqKnowledge integrates with the Argus glasses for in-lab and remote mobility. The glasses can provide real-time eye tracking data during the lab or log data and synchronize with BioPAC's data logger. AcqKnowledge interfaces with the BeAlert headsets X10 and X24 and the real-time cognitive states metrics for workload, engagement, and distraction. It also integrates with the Apex 32 channel system for in-lab and remote use cases where medium density EEG is a requirement. The Bioinformatics logger can also be used to support remote data collection. The Axon R AR headset for brain-computer and human-computer interface control applications also seamlessly integrates via the lab streaming layer feature in AcqKnowledge. The Research Ring is a lab on a finger that operates via an iPhone app or communicates with a laptop. In the latter case, you can collect data from up to 9 different rings. The BioHarness is a strap around the torso device that operates in real time and logs data. This is ideal for collecting long-term data from exercising participants. BioPAC offers a complete range of VR solutions for single and multi-use scenarios with options for head-mounted displays and 3D projection systems. And if those devices aren't enough, there are options to add further devices via LSL and to access data via network data transfer. Tim will provide more details about these later in the webinar. To summarize, AcqKnowledge makes connecting additional devices straightforward, starting all the devices with a single click of a button and combining all the signals into one single graph window, making it easier to view, prepare, and analyze the data. Okay, so that's the theory. I'm going to hand over to Brenda for our first poll of the day.
All right, thanks, Fraser. Let me just get this poll loaded up here. All right, that's going. So we'd like to hear from you about what signals you guys are collecting. Are you seeing the poll? I'm not. Okay, there we go. I see some results now. Okay, great. All right, well, just for fun, while we're waiting for people to answer that poll, we've got people from China, Mexico, several countries in Europe, Spain, Denmark, Brazil, UK. Looks like we've got people from all over the world today. This is such a great technology to be able to do that. I don't know what dot. I think that's .lt. Yeah, this is great to have all of you guys joining us. Thank you so much, India. I'm not going to try to say your name. That one's a tough one. Okay, let's see how we're doing with the results here. It looks like most people are, well, it's physiology data, so that's a large group of different types of signals. But then also EEG is a very popular signal that people want to collect. And then it's pretty much spread amongst the other signals, FNIRS, eye tracking, and facial expressions. I'm just going to give that another, people are still voting, so I'm going to give that another couple seconds. And I think that's a wrap. Okay, well, thanks everyone for participating. And now it is time to switch gears to Tim. Tim, I'm going to make you presenter. Are you ready?
Yes, ready to go.
Okay, here we go.
And just confirm, you can see the screen and everything?
I now can see your slides. Yep.
Okay, perfect. So yeah, we'll jump back and forth between this and AcqKnowledge a little bit. But again, thanks everybody for joining us. And I just kind of want to run through kind of the back end on this, because obviously when we're talking about multimodal, as Fraser mentioned, we're talking about getting data from multiple systems together under one roof. In this case, the AcqKnowledge software, everything basically streaming into that. And in most cases, you can go both ways. So not only can you get data in, but you can get data out, of course. So we're kind of touching on both a little bit, but do be aware of that it's not generally just a one-way communication. Because when you're talking about biofeedback type applications, it's going out, going back in, and sometimes even going back in again to create those biofeedback loops. And there's different modalities for doing this. There's we've got analog, digital, network data transfer, the newer LSL lab streaming layer. Even Bluetooth can play a part of it in getting information in from one system to another. But then on any of the third-party systems that we resell, the benefit is we've done all that back-end work for you. So regardless of what, we basically have kind of done the back end, and so it makes it very easily a plug-and-play situation. If you are dealing with systems that we don't resell that are other third-party systems, generally there's still a way to do it. And it's just kind of working with your local rep to figure out the how-to behind it. One of the methodologies of that is analog. Analog has been around obviously forever. It's always said that we live in a digital world, but analog started it all. And so whether you're dealing with an MP150 going way back in the day, 20 plus years ago, up to the newer MP200, you can get analog signals in or send analog signals out prior to them being digitized or run through the A to D converter. The way that's accomplished hardware-wise on our systems is through one of these. So if you're going back to an MP150, you'd be probably using a UIM100C, whereas this is the newer AMI100D. They're similar units. The inputs are a little bit different, but other than that, it just provides analog access, both inputs and outputs. So basically, if you have a third-party system that provides an analog output, you just need a physical connection into this unit via cabling, the correct cabling, to pull that signal in. So it's a very easy, on the hardware side, it's extremely easy. On the software side, let me quickly jump into AcqKnowledge. So once in AcqKnowledge, in order to enable those analog channels to take in that data from a third-party system, just under the MP160 menu, it's a matter of just setting up the channels. And if you're familiar with AcqKnowledge, hopefully you're familiar with this, you can add channels either by adding a new module or just going down and viewing by channels and basically just turning the appropriate channels on that are going to be used to pull that information in. So both from the hardware side and the software side, there's really very little to be done in order to pull in data from third-party systems. Moving on to digital then. Digital is basically just, for the most part, on-off data. So we're not really talking about physiological data at this point, pulling in, ECG, EEG, different things like that. In this, we're basically just talking about discrete values, on-off, low, high, generally represented by just something triggering 0 to 5 volts. And based off this information is usually what we then queue off of in order to create events that allows us to do event-related type analyses and things like that relative to the physiological data. So whether it's a single push button, whether it's a pad like this that allows for multiple subject responses, or sometimes you can use dials or different things, those are all coming in generally as digital signals. And so again, on the hardware side, on our end, on the BioPack end, generally you're using what we call the STP100C or the STP100D. And on that, we have either a trigger input, Again, just the physical connection is needed via cabling from one system into our system, and that can be used to start acquisition from a third-party system. We also have 4 channels of digital output here that can be used to trigger and send triggers out. But generally, we're taking signals in, and those are available here on the back by both a 25-pin and a 37-pin connector. So most of the time, those come into play when using packages such as SuperLab, ePrime, Media Lab, things like that, where you're running a stimulus presentation on one computer, making a physical connection from that computer to our system, again, via the STP100C or D, and then we're able to take in those digital signals that then mark the specific events that are of interest. On the hardware or on the software side, again, it's very similar to the analog that we just covered, to where we just go to the MP160 and the Setup Data Acquisition menu. And in this case, we're simply going into the digital channels and enabling the appropriate digital channels and turning those on. And really, that's all we have to do on our end, because at that point, the software is ready and just waiting to receive that information. So those channels are on and just basically waiting to receive. So the work is really done in the third-party program, ePrime SuperLab, to where within that program, you're having to code when markers are to be sent. And on our end, as long as these channels are on, we're going to be receiving that data. And this here kind of shows an example, which we'll use this in a further example more towards the end of the presentation. But basically what we're seeing here is obviously we've got a raw ECG channel, and then we actually have 4 channels of digital inputs. So each one of these markers here, we've got the green, kind of the fuchsia or pink, a maroon, and the red. Each one of these is coming in from, in this case, I believe it was a SuperLab experiment. So these markers are all distinct markers coming in across 4 different digital channels. And in the end, we'll use those markers again as points of reference in order to extract information relative to those periods of time. Moving on to network data transfer. Now, this is a process of, there's really not so much a physical connection anymore, but now we're dealing with a network where you have multiple systems all streaming data into a common local area network. And data is sent over packets, and then those packets are basically transmitted, reassembled, and the various systems have access to those. So it's not necessarily, I mean, it's definitely a newer technology, obviously the analog, but you can also get more information within both network data transfer and the lab streaming layer. You obviously want a fairly fast network because there can be limitations in terms of bandwidth and latency. So being on a good speedy network is always helpful with those types of things, because the goal is always to get as real-time information as possible. So we don't want latency issues or bandwidth issues where you're buffering and things like that. Now, in terms of kind of a nice example of network data transfer, I've got a short video here. It's about 35 seconds long. And this is a kind of cool example because we're bringing in information from a bunch of different sources. So we have a subject wearing a head-mounted display. And obviously with that, there's, well, not obviously, but with this one, there's also eye tracking involved. And they're also wearing our research ring. And so that is collecting EDA data, electrodermal activity, pulse data, which you'll see on this channel. And then down below, the heart rate is being calculated from that pulse signal, of course. Within the world, that the environment they're going to be looking at, in this case, is actually a grocery store. So several shelves, I think 4 different levels of shelves. And we've set up areas of interest on the different shelves. So every time they hit a different shelf and are looking at a different shelf, that's going to tag an area of interest as an event. And you'll see those events coming into AcqKnowledge in real time by the light bulbs above the signal. So we're just getting it set up really quick. And the other information we're capturing is we have a webcam. So we're actually using the media menu within AcqKnowledge to capture video footage, again, as Fraser mentioned, which is always helpful to capture. So we're capturing real-time video information of the subject. And we're also recording the scene camera, which is obviously the camera built into the head-mounted display. And so we've got both of those being recorded. So the scene should come on here in a minute. So there we go. You can now see they're basically standing in the store. They're looking at the different shelves. And the goal, actually, in this case, is to find the chicken nuggets. So they're being tasked with how quickly they can actually locate the chicken nuggets within the store. And again, over on the right within the AcqKnowledge file in real time, you can see the data streaming from the ring. So the electrodermal activity, the pulse, and then the pulse rate down below, which is right now he's averaging about 74, 75 beats per minute. And again, the light bulb's coming in on top. Now this is a quick view of the hit areas of interest and where he spent his average fixation time. And then we'll just zoom into the data a little bit so you can see it a little bit clearer. And then we also want to show just how the media is synchronized. So again, as I mentioned, we captured information from a webcam to where we recorded the subject during the experiment, and that is all synchronized with the physiological data. So whether you open the media viewer and play from the media viewer side, or whether you go into the physiological data and click through that, everything is in perfect time sync, which is really, really nice. It's great for identifying areas of possible noise and where you might want to focus data. And then the other benefit we do, like I mentioned, we also are recording the scene camera information. So we can go in, we can pull up that file as well. And just like the webcam, the scene camera information is also perfectly correlated to the physiological data. So that's a really nice example showing kind of the richness of network data transfer from multiple devices and what can go in. It's by no means exhaustive, but it shows a really nice example. Moving on to lab streaming, this is definitely the newest technology out there. And you can always go to the Lab Streaming Layer website, because again, it's an open source software framework. And so just going in there, you can just see the slew of instrumentation and devices that are now utilizing the Lab Streaming Layer network. And basically this is, we'll go into a little bit more, but network data transfer is a little more general. Lab Streaming Layer is really geared towards physiological data for the research market. So it's more specific in terms of that. And long and short, how it works is a device can either act as a publisher, a subscriber, or both. So basically, the data from any device using the LSL backend can broadcast or publish its data to the network. And again, multiple systems have to be connected to a common local area network. Once that data is published, it's basically stored in the core and available in the core, which handles all of the synchronization and the management of the various data streams. And then various subscribers, in this case, AcqKnowledge, can log in, pick out those, find the published data that you're interested in and pull it into their software package. So, we'll show a couple examples of that, but whatever is published to that network can basically be grabbed and brought into AcqKnowledge, which is really nice. A quick example of that, and again, by no means exhaustive, but just a nice quick example, is this here, panic mode. So basically, what we've done, we actually had ChatGPT write the code in Python to basically find our mouse, broadcast the mouse XY data to the LSL network, and then AcqKnowledge is tapping into that and bringing that data in real time. And you can see, and we're doing this through the Vizard software platform, which is the virtual reality platform we work most closely with through WorldBiz. And so you can see there's literally like zero latency going back and forth. And so again, this is a one system. Obviously, at this point, we're just tapping into a mouse, but this could be numerous devices that we ultimately stream in. It can either be data like this. Fraser will show later on with the Apex EEG system, for example, pulling in EEG data. And the nice part is not only can you pull in the EEG data, but you can pull in other relevant information, such as the impedance data relative to those signals can also be brought in. So again, more information relative to the data can also be brought in. So again, they're kind of seen as richer examples of able to bring in data. Now, the difference between network data transfer and LSL is, again, network data transfer is a little bit more general purpose, and it's used basically more for events, control, and biofeedback. So again, within like the VR, we use VR examples a lot because it's so rich and there's so many things that can come from it. So whether you're looking at gaze events, somebody using either a data glove or the hand feelers and grabbing certain things, obviously full stimulus presentation. You can also control the start of AcqKnowledge and even loading of templates into AcqKnowledge. And of course, biofeedback, which applies to so many. So whether we're creating full feedback loops to where you've got the physiological data streaming into the virtual reality world, the virtual reality reading that data, and based on the physiological responses within the physiology, things can actually change and control what's happening within the virtual reality world, of course. LSL, on the other hand, again, is more specialized and really designed, again, for real-time collection of physiological data. And as you just saw here, we can tap in, for example, with VR applications, whether it's mouse coordinate data, joysticks, pupil diameter, so on and so forth. And then, as I mentioned, with the EEG, not only the raw channel information, but the impedance channel as well. So, and again, this is far from exhaustive, and Fraser's going to show, again, more of the systems that we do work with and the data that can be extrapolated from those using both NDT and LSL. So I will throw it back to you, Fraser.
Okay, 1 second. Let me get Fraser. I'm making you presenter. There you go.
Great. Thanks, guys. Thanks, Tim. That was a great presentation. Okay, so as Tim said, I'm going to focus on how you set things up in AcqKnowledge. And we'll start with some relatively straightforward ones. I'll show you some of the tools that are in there that can make life easier for you and streamline the workflow, which is always so important when you're using multiple devices. So I've launched AcqKnowledge. Those of you that are already using it, you should be familiar with this. And all I'm going to do is create or record a new experiment. And the first thing that comes up under normal conditions, let me kind of get these organized. The first thing that comes up under normal conditions is your setup channels. The launch wizard understands that you're creating a new experiment, and it's going to allow you to configure the device the way you want to configure it. So by that I mean, what modules are you collecting data from? If you're using any of our smart amplifiers, those will plug in and the software identify them. If you're using bionomatics, you just pick the device from the list. So that's sort of a single device operation. However, you can run multiple MP200s or multiple MP160s or an MP160 and an MP200, or any of the combinations of devices I mentioned at the beginning. And to do that, there's a hardware connection manager that will allow you to pick from a list of devices. If I come into MP200, down here we've got this option, Manage Hardware Connections. Now from that, you'll see the device that you've got connected. So I've got an MP200, the serial number here, my nickname for the unit, so I can identify it more easily. That's the one thing that AcqKnowledge knows it's going to be communicating with. But if I want to add another device, I can pick from a whole list, and you'll see some of these are grayed out and some of them are dark. But if I want to add another MP200, I can pick from any list that I've got access to on my device. And I've got this little device here, connected, ready to go. I'm going to update the clock on there as a real-time clock, so now I've updated it. Now I've got these two devices that I can communicate with. Once I close this out, if I adjust my displays, on the left-hand side, this is the my original unit. If I open a new window, I can pick the second unit. And I can now come in and configure it however I want. Close that. Here's the display. I'll just put that there. So now I've got two MP200 devices that I can collect data from. Now, at the moment, they're not communicating with one another. They're just completely independent. So I can start one ahead of the other. But more typically, you want to be able to start the devices together. So we have something in the software called linked acquisition. If you come down here, there's an option set up linked acquisition. This allows me to choose the devices that I want to link together. Now remember, I could have more than two MP200s. In fact, you can safely run 5 MP200s simultaneously. And you may want to start them all at the same time. So you would just pick all 5 of them, and then when you launch, both devices will start simultaneously. Down in the bottom right-hand corner, you can see over here, we'll say Start Acquisition. I'm not going to get into that at the moment. What I'm going to do is back out. Actually, no, I won't. I'll come back into Preferences, because this is where a lot of the controls that you probably don't typically pay attention to, but these can really help you. This is the Preferences dialog. On the left-hand side, you get to choose the preference area, and I want to go to hardware. So from hardware, you can select your priority list and enable or disable different devices. So if I know I'm using an Apex, if I use my right mouse button, I can enable that device and I can move it up the list. Now what that means, when we first launch AcqKnowledge, the software will look at this list and it will say, oh, Fraser's got an MP200. I need to find that. So the first thing it will look for is an MP200. Once it's found any MP200s, it will then say, oh, MP160 as well. And it will work down the list in order of priorities. If you want to disable an item, again, just right mouse click, and then you'll see it's grayed out. The list is quite long, lots of different devices that can be connected. So that's the first thing, enabling and disabling. Secondly, you've got how you control AcqKnowledge once the software is launched. By default, the system launches via this minimal channel setup mode. And by that, when you launch AcqKnowledge, the software doesn't know how you want to configure it. So it's going to say, okay, go ahead, pick the signals that you want connected to channel 1, channel 2, channel 3, so on and so forth. But many of us use the same configuration over and over and over. So launching with the minimal channel setup can be a little bit tedious, because then you've either got to open a graph template file with everything set up, but you can use the user-defined default acquisition setup. Now that setting will allow you to configure your device, pick the signals that you're collecting. Those will remain as a default. Every time you launch AcqKnowledge, it will start with those channels enabled, ready to go. So that's super helpful, particularly when you're doing it with multiple devices. Because if you've got two MP200s and you've got them configured identically, this is by far the easiest way to set everything up. Second option, linked acquisitions. I showed you within the menu there that you could pick linked acquisition. Well, you can make that by default. So because I know I'm always going to be collecting data from multiple devices, I want to use linked acquisition because I want both devices to start at precisely the same time. In order to do that, you can select use linked acquisitions whenever possible. This option here, merge data automatically, super convenient. You can collect your data. At the end of the experiment, you've got two discrete files, participant 1, participant 2. Once you've stopped, you can then automatically merge all the data into one file. You don't lose the two original files. You can still save those, so they're parked, but you've created this new file. The new file contains the time synchronized data of all the signals that were collected simultaneously, irrespective of the device. In the example I'm showing, it's MP200s. Once we've got everything in the one file, our analysis becomes much easier, and our cleanup, our viewing, our inspecting of our data to make sure the quality is good before we take any measurements and perform any analysis. So this option here, merge automatically, it will give you a couple of options. If you've got devices that have sampled at different sample rates, it will merge them at the highest sample rate or the lowest sample rate. You can pick, again, if you're doing two devices exactly the same, it's sort of irrelevant, this one. Then your data alignment, the default is the timestamp of the first sample. So it's going to look at the timestamp and align them based around that. So now I've got everything set up here. I'm going to clear what I've got going on. I'm now starting with a blank slate. So I hit OK. I'm going to close this one out, leave that alone. And I'm going to come back in here and I'm going to let's just make a pretend setup. Let's say, okay, I've got a bioinformatics module for pulse and electrodermal activity. And we'll configure that for channel 1 and channel 9. It's going to do a calibration, and I'm going to continue. And I'll add another module. I'll do respiration and ECG. Can't see it for looking. There it is, respiration and ECG. These are sort of typical devices that people use, and I'll put this on channel 2 and channel 10. It's going to run through, do this calibration. This option here, I'm going to disable this, and I'll get into that in a moment, but it prevents you from running through a calibration again. Once I hit close, the system's going to ask me, do I want to save the hardware settings? I'm going to say yes. So now I've saved these hardware settings. If I close out, I'm back at my startup wizard. I know I've got two devices connected. I want to launch both of my devices. It's launched them. It's arranged them on my window for convenience. And I can, if I just come in, we'll come back into this first one. Oops. We can see this is set up with my default settings. I'm going to come over to my second one. And again, it's got those default settings. Now, if I start, immediately it brings up that linked acquisition. I hit start linked acquisitions. It's just reminding me to change the data acquisition mode to save once. Both of my MP200s have started simultaneously. It's collecting data from all the channels. At the end of my experiment, I can hit stop. Now I'm going to save the data. So now I've got a file of my combined signals from both MP200s. Okay, so in essence, we've got 3 files. We've got the file from the first MP200, same for the second, and now this third one with all the combined information. So you can see that once we know how we want the system set up, we can really make it very, very efficient. Our workflow becomes super convenient. So I'll close this out. We're back here. And again, I can start these independently. I don't have to use all devices, or I can start them both together. All right, so that's one quick example. Next one, I've got a video that I'm going to show. And bear with me for 1 second while I get that queued up. This one's going to show you exactly the same thing again, only instead of, actually, that's not the right video. Let's try that again. There we go. So on the left, we've got an MP200, basically the same unit I set up. But instead of running a second MP200, I'm going to connect to the Argus eye tracking glasses. Now, one of the nice things about the integration we have with the Argus glasses is if you're in the lab, you can bring in an amazing amount of data from the glasses in real time. I'm showing you this manually. This is a quick look at the information. You'll see this in a little more detail in a moment. So again, we've got 2 windows. One of them is for the glasses on the right. One of them is for an MP200. These are all the different channels of data that can be pulled in from the glasses. I'm only just pulling in a few of them. I think they're the default ones actually, but the sample rate from the glasses is really nice, 180 samples a second. You don't have to really worry too much about the configuring of it. AcqKnowledge takes care of all of that for you. All you have to do is select the channels. Again, we've got linked acquisition mode, and I'm using a feedback loop here, I didn't have myself connected, but you'll see in a moment that once we start, I've got to get the glasses enabled. You'll see that, here we go. So there you go, this is me putting the eye tracking glasses on. You can see the gaze point, the top, where we've got the 2 views of the eyes. You can see the pupil is identified. You can see the 2 glints. I just did a calibration, and that was me just tracking my finger across the screen. This needs to be set up and running in the background. But again, it's easy. Once you launch it, it comes up. There's some settings in here. The most important one is where you want the file saved. I've already taken care of that. You can also configure the video that's being selected, and you'll see what I mean by that in a moment. So we're going to bring in the scene camera video. And once we've done all of that, we'll be ready to record a little bit of data. Okay, so that's in the background. Away we go, we hit start, changing mode to record once. So now this is live, we're recording data. On the right-hand side, I must have paused and changed this around. Now on the right-hand side, I've got the physiological data. And you can see I'm recording heart rate and R2R interval. On the left-hand side, we've got a few channels of data coming in from the eye tracker. And I'm going to auto scale these, and then you'll see me look left, look right, and you'll see the the data come in. I'm just going to advance this forward a little bit. This is me after I've collected the data. It's now asking me again to create that single file. Okay, so now I've got the third file with my eye tracking and my physiological data. Under normal circumstances, the playback will open up automatically for you with the scene camera file, but you can do this manually as well. So this is doing it manually. So now the scene camera will appear on the screen. Get this organized. There we go. Okay, so now the scene camera video is fully synchronized with the physiological data. So anywhere you place the cursor, it will advance to the corresponding point in the physiological data. And, you know, you can come through to areas like this where, you know, move forward a little bit, where I'm looking eyes right, eyes left. You can click on the different areas and you'll see the gaze point move around based on where the cursor is here. Anyway, that kind of shows you multiple MP devices, eye tracking with MP200. Again, all of that's done within AcqKnowledge. Workflow is relatively streamlined once you've got everything set up. Anyway, I'm going to hand you back to Brenda for our second poll of the day.
All right, I'll go ahead and launch this poll. And then I do have a question, Fraser, while the poll is going through from Gregor. Is it possible to link an MP200, a couple research rings, and the old MP150 when using the linked acquisition command?
Yes, you can set up combinations of devices. I'm saying yes with the MP150. I've never tried it. In theory, it should work. But yes, you can. And oddly enough, one of the demos I was going to do was MP200 with ring, but I decided on a different combination. But I'll show multiple rings in a moment. So yes, the answer is yes, you can run the different devices, specifically the MP150. I'm kind of hedging my bets a little bit there because I've never actually tried that myself.
Okay, well, great. So let's just take a look at these results here, working with multiple devices. So it looks like, okay, so almost half of the people are 2 to 3 devices, with a third being 1 device and much smaller percentages for 4 to 5, 6 or more, and other. I'm curious what the other is for the one person who responded other. Feel free to send that to me over a chat or a questions. And then Alyssa, I see your question and I answered it. Let me know if you want more elaboration on that later in the webinar. All right, I'm going to go ahead and end this poll, and back to you, Fraser. I don't hear you, Fraser, so is it possible that you're muted?
It's 100% possible that I'm muted and 100% possible I don't have my camera on. Thank you. We all good? You're seeing my screen? Yes, you are. Okay, perfect. Sorry about that. So what I was just saying is, what I'm going to show you now is how to connect the rings. So again, we've got the system set up. I've got actually 2 research rings here. And I'm going to make sure, first off, if we come into our hardware setup, I believe I have this configured for the ring. I do. I'm just going to put that to the top of the list. And I'm going to disable these for now. Hit OK, hit OK. And I'm going to come into Manage Hardware Connections. I'm going to select Research Ring. And now I can see if I put these two rings on, I've got rings 93 and 55. And I'm just going to slip these on quickly. So one on each finger. Actually, I can only do one at a time at this point. So I'm going to connect the one. And it's connected to that first one. And what I'm going to do is connect a second one. So this is the second one. And now I've connected to the second one. And you can tell when these rings are connected. Hopefully I can show you this. Can you just see there's a green LED there? That's letting me know that this is connected to AcqKnowledge, and on the other, it's a little bit difficult to see on there, but green LED is illuminated once I've got this connected. And again, if I come back in here, I've got these different options that I can connect to. So I can pick one or the other. I'm going to open one up initially and move this over. So once you're connected to one of the rings, it will give you the battery level. It will allow you to identify that particular ring. And hopefully, if I do that again, you can see that it blinks. So I know I'm connecting to that one ring. I'm going to come over here. I just want to do one quick thing. I'm going to disconnect that. So now I've just got my two rings, because what I really wanted to show you is, okay, so I've got these two devices here. I can hit OK. Now I've got everything set up. I can start recording. And in a second, we'll see the data from the two rings. And it takes a little while for it to identify the signals. You can see the top channel is the pulse waveform. And the second channel is EDA. And it goes for a few seconds until it's optimized the best pulse signal. And then it will kick back in until it's happy with it. You can see it's just going through the process. That's normal. If I auto scale these, and I'm going to auto scale this, you can see the EDA. And maybe if I take a deep breath, we should see an EDA response, and we do. All right, so the same applies to these. If I hit stop, it immediately asks me to create a new graph, and I'll save that. So now over here, I've got all of that data that we just collected from both rings. Pretty straightforward. Same setup, managing the connections. Once you've got it connected, if you're only using the rings, it will just allow you to launch all of them at the same time. The other thing, once the rings have been connected to the device, it remembers them. So each time you launch AcqKnowledge, it's kind of used to those devices, and it will identify them again. I'm going to close this out, the combined one. Come back into one of these. Let's have a look here. Down below, I wanted to mention this. You can see the maximum allowed number of rings is 9. So that means that on this particular computer, I could have 9 people, each wearing their rings with all the data coming back. And they can all be started at the same time. just the same way we did with the two. So super convenient there. All right, so what I'm going to do now is ask Brenda to turn on my other computer. All right, Ian, I'll turn my camera on. Okay, perfect. So I'm just doing this demo on a different machine. I had everything configured. So it's a little bit easier than switching backwards and forwards. So what I'm going to show now is I'm going to make sure that I'm out over here, so bear with me. There we go, perfect. All right. So what I've got is the Apex. This is a 32-channel EEG system. I've actually physically got it connected via USB. I'm not going to put an EEG cap on myself for this demo. You just have to trust that it can record EEG. But what I wanted to show is the setup and how we can configure the different devices. So same thing, the software knew I had already had this configured. I've got the same MP200. I'm now connecting to it via this computer. I've got the Apex connected, and I can launch both these devices. They both come up on the window exactly the same. Can't remember how I've got this configured, but let's just see if we can at least put something on the display. I do have a loopback cable here, so all I'm going to do is output a waveform and feed it back in. So hopefully if I've got this set up correctly, when we hit start, again, we've got our linked acquisition. We can start acquisitions. We're going to change that mode. And now both these devices will start. On the left-hand side, I've got this sine wave that I've output from the stimulator and I've fed back in. On the right-hand side, you can see this is all the channels enabled, but I've got a little simulator connected, so I get 8 channels of EEG signal. The rest of them are just flat lines. But I'm going to stop. Again, I get the option to save. I've got this combined file with everything in there. But what I wanted to do is just come in here. So this is within the Apex setup. Again, BioPack knows that this is a 32-channel system. It, by default, enables all the channels. You can turn those on and off. So if you only want to display a subset of them or record a subset of them, you can do that. This data, although the device is connected via USB, at the moment, the way I'm running it, the data is actually being sent using LSL. The Apex has different modes of operation. I've got it tethered. The nice thing about running it in tethered mode, it's you guaranteed the connection. But if you want more flexibility, there's a Bluetooth dongle. You can run it with Bluetooth. It's also a data logger, so you can record the EEG when the participant is away from the lab. If you want to collect other physiological signals, you can use either the bioinformatics logger or the ring. If you use the bioinformatics logger, you get different signal combinations, but the point is that data can then be brought back in and merged after the fact. I only have one camera on here, but we could be recording the video as well. Can only use the video through GoToWebinar. But anyway, the point is we're showing you these different devices that can be connected and the different combinations and how easy it is to do that. One other thing I should mention, when you come into any of the devices, Tim will talk a little bit about this in a moment, but you've got the event marks. Any event marks that are entered into the system in either of the devices, they all get merged into that third graph as well. So not only do you get the data, you get the event marks as well. So anyway, that gives you a very good overview of the simplicity of using the linked acquisition and setting everything up. I'm going to hand you back over to Brenda for our third poll of the day.
Okay, and here we go, launching that poll. And then I'm going to let you get set up over there, Fraser. Let me know when you're ready for the next demo. One thing that I'll share with everyone is, so Tim, I'll ask this question of you if you wouldn't mind just unmuting yourself real quick. Alyssa had asked earlier about having a parent-infant webinar, parent-infant study where she collects RSA data, and those can come into 2 channels on the same machine in one AcqKnowledge. Could you just explain how that works a little bit?
Yeah, generally in that case, we're just running, usually you can go with a wired setup, but a lot of times going with the Bioinformatics wireless works really well, because that way it gives more flexibility for the mother to hold the infant. And again, the only thing they're wearing at that point is a 3-lead ECG, a respiration strap, and they basically have the ability to, the one MP160 or one MP200 is in the local room with them. And so they're able to, whether they're sitting down on a couch or getting up and walking around the room, bottle feeding, anything like that, being wireless is really nice. And we have a lot of people doing that very same application.
Okay, great. And they can all come into the same AcqKnowledge. You don't need to have.
Yeah, because again, the MP system can collect up to 16 channels. So yeah, you can collect not just the ECG and RSA, but if you'd want to do temperature data, again, you've got all 16 channels to use off of. So there's no reason in that case to go into separate systems. Okay,
great. So go ahead and end the poll. Thank you. Wow, 3/4 of people are one participant, with it equally matched on the other categories there for multiple. So thanks everyone for participating. I'm going to go ahead and end the poll. And then Fraser, I'm going back to your other computer, right?
You got it. Yes, please.
There you go. I'm making you presenter. Thanks, Tim.
Thanks, Brenda. Can you send me that again, Brenda? It's not. I'm not seeing it.
Yep. 1 second. Let me make myself presenter. Okay. And then go ahead and close that. I'm going to try you again. Make you presenter. Let me know how that worked.
Got it. Got too many windows open. All right, so the last demonstration I want to show you, actually it's a hybrid video and real live analysis, so I guess pseudo real live. This is a combination of physiological data with eye tracking, face reader, and video. So sort of definitely multimodal. It also includes the stimulus presentation. So BioPack includes the stimulus presentation and the eye tracking analysis stuff. The face reader is a third-party product. So any of you that are doing facial expressions, it's kind of a pretty elegant tool for that. You don't need any electrodes. A lot of people like to do facial EMG, but this is kind of an alternative strategy to that. So on the screen, what you're looking at, in the background, this is Face Reader. And you can see me on the camera. The camera has to be facing the participant's face. You can run Face Reader two ways, off of a recorded video or real time. So the way I'm demonstrating it is real time. In the foreground, you can see I've got AcqKnowledge set up, and I'm using the stimulus presentation. And I'm just going to play the video from here. So I had a stimulus presentation that was already configured. Once you go into the StimPres, you can connect the device. So I'm using an MP200. It's that same unit that I've been using all day. I'm using a template that just happened to have Pulse ED, EDA, and I was actually connected to myself, enabling the eye tracker and face reader. And then it just tells you that it needs to be in save once mode, which we've selected. Once you hit record, it will launch the stimulus presentation and eye tracking components, as well as face reader and the physiological data. There's a little sort of precursor you have to go through with the eye tracker. First of all, you want to make sure you can see the participant correctly, and you can see the little crosses, one over the pupil and then the two over the glint reflections. Then it's going to do a 5-point calibration, and you can control the number of points. 5 usually works quite well. This is using an iTech remote eye tracker, but we interface with iLogic, Logic 1, and also the Tobii eye trackers as well. Once you've done the calibration, it will give you these little hourglasses over the target, so you can see how accurate the tracker is, and maybe you want to redo it. In this case, I've moved on. Now, basically, the participant, which in this case was me, will receive whatever presentation you've got put together. And, you know, we've got a fixation between, we've got a series of images, and the technician's view, they're seeing precisely where the participant is looking while this is going on. And I'm going to skip forward because I think we all get the idea that, you know, it's a presentation of images, and we get to the point at, I'll play it from here, this is the last one. We're done. We've recorded the data. You can see the physiological data in the background, and voila, this is everything. And I'm going to hold it right there, and I'm going to open up the real data so that we can look at the real data. So I'm going to close out on that, and over here, plop that over there, and get the eye tracking, and get the video. So bear with me while I get my screen dialed in a little bit. Oops. There we go. Okay, so on the left, we've got the physiological data. Over on the right at the top, we've got the eye tracking. This is just a heat map. And down below, this is the scene camera from the video. I've closed some of the channels down just to make it a little bit easier. The top channel, this pink channel, is electrodermal activity. Then we've got some information coming in from Face Reader. And in particular, this is happy, this one channel here. So in theory, if I come and I click in this region here, down below we can see, yes, I'm definitely happy at that point. Or over here, you can see I'm not so happy, and this channel here is sad. Yes, very sad. So that's the face reader component. It's completely time synchronized, surprise, etc., etc. So face reader, these are exaggerated expressions, right? I think we all get the point. The face reader will determine what the person's facial expressions are while they're performing a task. And in this case, it was looking at the stimulus presentation. So I'm just going to close this part out. Down below here, we've got our video, eye tracking. I can advance across to any of these, and we can see precisely what's going on. Okay, I can hit the gaze path, pick a point, and I can hit play, and away we go. Okay, so that's sort of another example of eye tracking, multimodal with face reader and everything else. I'm going to hand quickly over to Tim just for the final segment. So Tim, back over to you.
Okay, thanks, Fraser. You're definitely doing the heavy lifting on this one. And I know we're over time, so I will try to go through this pretty quickly. And we just kind of wanted to wrap things up by showing a workflow editor a little bit and events, and just how it can assist with, ultimately, once you get data in, and not only do you have your physiological data, but now you've got event markers coming for different sources, how you can utilize those to kind of automatically extract data, from the software for analysis. And quickly touching on the events, of course, again, you've seen this file before, and so we have some event channels already in place that were coming into AcqKnowledge from third-party systems. But if we also want to record events, and a lot of people don't necessarily know about this, and so I'd like to point it out. So we do have event marking in here. And this event marking applies to manual markers inserted basically using either the escape key or any of the F keys on your keyboard. And so whether you set these up or not within this dialog box doesn't really matter. Anytime something happens, and if you just want to mark it and you're collecting data, all you got to do is press one of the F keys and it's going to insert a mark there, F1, F2, F3. And so if something happens with the subject that's kind of random or out of the ordinary, or they cough or something like that, and you just want to quickly place a marker, you can just quickly hit one of the F keys and it's going to put a marker there for reference. And you can type text to it later on after the fact. But if you do have a protocol that maybe doesn't require the millisecond precision of a third-party device sending in triggers, and manual markers are okay, and you have a dialed-in protocol of step 1, step 2, step 3, or condition 1, condition 2, condition 3, so on and so forth, you can pre-program these. So you can basically set the key, set the F1 key in this case. You can set what type of marker you want to insert, and it can literally be anything, from waveform onset to a simple star to a specific hemodynamic thing such as a T-wave peak. So I mean, basically whatever you set here is what it's going to put. So we'll just put a star in this case. You can have it be fixed. So we'll just say event 1. And if we want to set the F2 key, again, you could set that to be a flag, and that's event 2. You can also choose where you want the event to be inserted. If you say global, it's going to insert the event up here above all of your data, or you can put that event and tag it on a specific channel. So basically just know that that exists. And again, once those events are in there, the beautiful thing is AcqKnowledge can then queue off of those events to extract measures. So most of that is done under the find cycle routine, and we definitely don't have time to do that. We actually have I believe seven distinct YouTube videos that go through the find cycle routine in detail. And if you're not familiar with find cycle, I definitely encourage you to go to the Biopack YouTube channel, look up those videos regarding find cycle, and familiarize yourself with it, because it is a very powerful tool within AcqKnowledge to automate the extraction of metrics. What we're going to do here actually is quickly run a couple of workflows. And the workflow ties in with scripting, but the nice thing about workflow is you do not have to write a script. You don't have to know BASIC. So it's a GUI interface, and I'm going to open one of two workflows. The first one, all we're going to do is just cue off of these R wave peaks here, and we're going to mark the peak of each R wave. So I'm going to play that through, basically run the workflow. I will rescale quickly, and you can now see that all of the R waves are marked now with a flag. Now, prior to doing any other analysis, I would go through and visually inspect that and make sure that every R wave is accurately marked. If it's not, you can obviously correct it and do what's necessary. I've already done that, so I know that everything is good at this point. So now I'm going to jump into my second workflow. And this one is a little bit more involved. As you can see, I'll scroll down here. There's several steps. But basically what it's doing is the first thing it's going to do is cue off of each peak here, each marker that I've set, and extract the heart rate data. So we'll get a new channel with the heart rate data. Once that's in place, it's going to convert all of these digital channels, all of these markers here, to events that AcqKnowledge can then recognize. We're then going to find those events and take heart rate measurements, find the value of the heart rate at that point in time for each distinct channel, for each distinct condition. So I will run it. Then immediately you'll see we've got the new channel there, the green one, the heart rate. And let me go back, because the beautiful thing about workflow is it runs very quickly. So instead of having to do all this manually, it's done in an instant, basically. So again, we now have our heart rate channel here. We've had AcqKnowledge identify all of the distinct events. So we've got an event on channels, the digital channels, 28, 29, 30, and 31. And then we've basically told it at each point where these events exist, take a value of the heart rate. So, and spit it into Excel. So we have 4 distinct Excel files related to, again, here, channel 28, 29, 30, and 31. So as an example, if I go back in, at my very first marker on channel 28, it extracted the heart rate value of 59.288. So if I go in here and zoom into that area and take a value reading at that point, at that marker, boom, 59.288. So it's done that automatically, just in a blink of a button. So the workflow is an extremely nice tool, especially if you've got multiple people dealing with your data. Again, you get those workflows in place, and instead of having to go in and have, literally a 5-page document sometimes of step 1, step 2, step 3, it's all in the workflow. So literally all I have to do is go in, hit the start button, and if you've got 20 files over here in one folder, you can direct it to that folder, and it'll go pick one file, run the workflow, pick the second file, run the workflow. So it just automates things and creates much more continuity and really accuracy, I think, as well, in terms of your overall data analysis. So that kind of wraps it up here. I know we went long, but definitely thank you for staying, if you did. And I'll give it back to you, Brenda.
All right, a lot of people did stay, so thank you, Tim, and thank you, Fraser, for putting this together. It was a pretty big webinar, actually. So let me go ahead and share my screen.
And if we do have questions, that's good too.
Yeah, I think we're good. I've answered a few questions along the way. I did want to share that we have webinars throughout the year. We have over 100 webinars actually, and I just share that. I know Alyssa, you were asking about the parent-child, so here's a dyadic webinar and multiple participant or large group webinars, but you can just scroll through our webinars and see what else interests you. Also, if you scroll down to any page of our website, I know a couple of people asked for more information about pricing or additional info. But anyway, if you scroll down to any page on our website, you can reach out to your local sales representative. You just click this button right here, complete this form. Mine is Amy because I'm in California, but yours will be yours in your area. And if you submit that, it'll send an email to her right away. All right, now, so let's just see here. I got to get my screens organized. Oh, there's another thing I wanted to tell you about. We offer workshops in each of the different regions. And okay, now I've got my screen. Okay, so we do host workshops in each of the different regions, and we host them at universities. You can invite people in your regional area or just at your university, and we'll come to you with this equipment and teach you how to use the equipment yourself. And it can be a much longer day. We can have even multiple days of training for you. Anyway, it's a great way to learn about the different options for you and get more experience. We've hosted these all over the world. The next couple are coming up in Denmark and Germany, so feel free to scan that QR code and sign up for the one in Denmark, or sign up for the one, submit a form to me, and then I'll forward it on to the correct person in your region. Also, if you missed it at the beginning, we have our 4T conference. That's a human physiology training conference that's coming up in July in California. So feel free to join us here in California in July. So Fraser and Tim, thank you so much. This was a lot of work that you did to put this webinar together. And I know people appreciated it because I could see how engaged they were on this webinar. So I'm just sharing with everyone now that today's webinar was recorded. We'll send each of you a link of the recording and any additional documentation. When you close the webinar window, you'll see a survey. Please complete that so we have your feedback and ideas. You may visit biopack.com for additional references. Like Tim mentioned, there's several videos on Find Cycle Detector. You can also find other screencasts on different features and analysis tools, application notes with step-by-step instructions, upcoming webinars, and events. And that is, I think, a wrap today. Speakers, anything else before we conclude?
No, have a good rest of your day.
All right. Well, thanks everyone for attending. Appreciate it. And have a great rest of your day.
Thanks, guys.
Great holiday season and end of year if we don't see you. Okay. Take care. Bye.